Welcome to Penrose Learning, where we make understanding easy.
You start by working on a RAW or lossless file so you keep all image detail. That matters for deconvolution. Once loaded, isolate a high contrast patch. Edges reveal motion direction, so crop a 512 x 512 area and inspect strong edges. Then compute an initial point spread function, or kernel, by profiling edge blur. This gives you the first approximation of how the camera moved. Do this now because a better kernel means cleaner restoration later. It reduces ringing and preserves texture. Once you have a starting kernel, run blind deconvolution and alternate updates. Fix the kernel while restoring the latent image, then fix the image while refining the kernel. You must regularize, use L2 or total variation constraints, because it prevents noise amplification when recovering high frequencies. Gradually reduce smoothing as iterations progress so fine detail returns. Monitor residuals and the kernel shape every few iterations. Make small kernel size adjustments if the motion tail is missing. This refinement is the core of removing motion blur accurately. Now run a final non-blind deconvolution across the full resolution RAW, using the refined kernel to restore detail. After that, apply gentle denoising and subtle sharpening to recover texture without creating halos. You want natural edges, not ringing. Save as a lossless file. If things go wrong, if ringing or smear remain, revisit the kernel. Increase length, change angle, or pick a different high contrast patch and repeat estimation, because the correct kernel is the single most critical element for success.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.